Hello everybody, so today we're dealing with Trigonometry chapter 22, exercise 22E and question number 32. So this question states that all edges of a square-based pyramid are 12 meters in length. First thing we have to see, it's a square-based pyramid, that it has a base that is a square, and then of course it has slant edges like this. Then it says that all the edges are 12 meters. Now, looking at this, most the confusion that is there in students' mind is that this edge, this edge, this edge, and this edge are 12 meters. But they forget that this edge and this edge, the slant edges, are also 12 meters. So when we're given this information, what we have to pull out of this information is that this, and this, and this all are 12 meters. Now, having known this, we're going to move on to the first question, which says that find the angle between a slant edge and a base diagonal. Now, first things, what is a slant edge? A slant edge is basically this edge, what is written as lateral edge, this and this. It is not the slant height. Slant height is this, that is perpendicular to this triangle, the edge triangle of a pyramid. So, having known that this is the slant edge, what's base diagonal? The diagonal that cuts through the base. So, this is the base diagonal, this is the base triangle. So, we can consider any one of those. We're going to consider this and this slant edge. So the angle between them, this angle theta, is what we have to find out in this question. Now, another thing to consider is that this is the apex of the pyramid, and it corresponds to the center of the base. So if I draw a perpendicular line here, this is the perpendicular height of the pyramid. So this makes an angle of 90 degrees with the diagonal, because when the diagonal intersect, they intersect at the center of the base, that is a square, and it corresponds to the vertex, the apex of the pyramid. Now, having known this, we can kind of erase this figure and we can look at this figure. So in this figure, we're gonna draw our base diagonal like this, and of course these diagonals intersect at point. Let's name the point O. So we know that this right over here corresponds to this, so this would make an angle of 90 degrees over here. This is 90 degrees. And what the angle that we have to find out is this angle, theta. Let's name it theta. So, when we have drawn this figure, we can start moving on to the first, solving the first question. So, starting to solve it, it says that we have to find an angle. So, to find theta, the first thing is we have to find the length of this and this. This we know it's 12 meters, as we already said, but we have to find out this length. And to find out this length, we have to find out this length, and to find out this length, we have to see that this is a right angle triangle. So this, if this is x and this is y, so x square plus y square is equal to this side square. So we'll write in triangle, DBE, angle E is a right angle. Okay, because why? Because it's a square. Okay, so this is a right angle. So from here we can say that DB square is equal to BE square plus DE square. How? We have to mention because of Pythagoras theorem. Now, having known this, we can say that BE is 12, DE is 12, so we can say DB square is equal to 12 square plus 12 square. So DB square is equal to 144 plus 144. That is DB square is equal to 288. What is DB then? If we take the square root on both sides, we get DB is equal to root 288. Now we have to find, as we said, that we have to find this DO. So we know that as the diagonals of square bisect each other, okay, so they kind of like cut themselves into equal parts, bisect each other. So DO is equal to DB divided by 2. So DO is equal to root 288 divided by 2. Now I would recommend you not to like put it into exact values right now, like not put DB into exact value, because at the end we won't really get the exact value. So we're gonna just like continue with this. So DO is equal to root 288 upon 2 meters. You can solve it, but I would recommend you not to, so because it sometimes makes the value a little bit not so accurate. So after knowing DO, we can look at theta. So if I kind of like pull out the triangle AOD, I see that AO is a right angle triangle. DO is equal to this length and AD is equal to 12. Now, to find out angle theta, we can use trigonometry. But what are we going to use? So you can write down SOHCAHTOA, that is SOHCAHTOA. Then you see that it's adjacent and hypotenuse. So we're going to use K. So it's going to be cos, because K, right? So cos theta is equal to adjacent upon the base, adjacent upon hypotenuse, I'm sorry. So adjacent is DO and the hypotenuse is AD. So DO is equal to root 288 upon 2 and the whole upon AD, that is 12. That will give us root 288 upon 24. That's 12 into 2. So now if we solve it, you can solve it in your calculator. If you solve it, you're gonna get theta is equal to 45 degrees, and that's the answer. You're gonna write answer is equal to 45 degrees. Now it's not really done over here, like you're not done here. You have to find now the B question. I'm gonna rub this for making space for the B question. Now for the B1, we'll start by saying show. It says that show that this angle that we just found out, that theta is equal to 45 degrees, is the same for any square-based pyramid with all edge lengths equal. So for any square-based pyramid, so the only thing that is changing, so we know 12, it's 12 meter here, but we said that if it's any meters, like if it's 8 or 10 or 100 or 2000, so for every of that length the angle is going to be 45. So what we're going to start by doing is that we can if we are giving the angle here, if we are giving the length here, we can just say let the length of the edges be x. Okay, because we said for any, not for specific. So when we say that it's x, we can solve that. Then we can say that then db square is equal to x square is equal to, so it's equal to dbe square plus de square. That would mean db square is equal to x square, because if this is, we're just saying in the next question that this is x, this is x, this is x, instead of being 12 or like any number, it can be any number. So x square plus x square, because this is x, and this is x. So then db is equal to root 2x. Okay, root 2x meter, but you don't have to write meter. Now if we know that db is equal to root 2x, so do is equal to root 2x upon 2. We don't need to say that again, that the diagonals bisect each other in a triangle, in a square. We don't need to say that. Now do is equal to root 2x upon 2. So what is angle theta again? So cos theta is equal to adjacent upon hypotenuse. So adjacent is do upon the hypotenuse, that is AD. Now AD is also equal to x, so AD is equal to x. do is equal to root 2x into upon x upon 2, but that would, okay, I'm just gonna elaborate it. Root 2x upon 2 whole upon x, that would be root 2x upon 2x, that would be root 2 upon 2. So cos theta is equal to root 2 upon 2. So theta is equal to 45 degrees. So, and hence, then we can write hence proven that you can just write hence proven that this angle that is 45 degrees is the same for any square based pyramid with all edge lengths equal. So yeah, that's it. Thank you.